Right, so this is the second class of the new school term, and last week we did the laws of directed numbers revision again. Today, a quick recap of those two laws, and today we're going to move on to simplifying like terms. Right, as I said last week, what is important for this term, we'll be focusing on algebra, and directed numbers is the key to algebra, right? So we're in here. So directed numbers, addition and subtraction of directed numbers to be specific, right? So when we add and subtracting directed numbers, there are two laws we need to know by heart. The first law is the same signs law. When we say same signs, we add and keep the same sign, right? Good. For example, plus 2 plus 7 is plus 9. Same signs, add and keep the same sign. Example again, minus 2, minus 3, minus 4. All you have negatives, same signs, add and keep the same sign. 3 add 2 is 5, 5 add 4 is 9, this is negative 9. We're good to go there, right? Okay, simple law. Next law is different signs. Different signs now, right? The law is simple. Subtract and keep the bigger sign. So example of that here is 7 plus 7 minus 3. These are different signs. So we're going to obviously subtract. As the law states, 7 take away 3 is 4. And keep the sign of the bigger number, positive 4. Point to note, right? Once a term is a first term, the positive is understood. Example again, minus 12 plus 2. This is different signs because the 12 carrying a negative and the 2 carrying a positive sign. So different signs, we're going to apply this different signs law, subtract, right? So the only way you can subtract here is 12, subtract 2. 12 separate, subtract 2 is 10. So we subtract and keep the bigger sign. In this case, the bigger sign goes with the 12. Negative is the bigger sign, right? So we put a negative here, right? Simple, right? So we can move on from this now. And we're going on today to something called like terms. I'll send you notes for you all, so you don't have to write this down yet, right? So don't hurry to write it down. Right. So today we're going to simplifying like terms. So just a recap from last term. What are like terms, right? Like terms are terms with the same variable. Right? For example, if you have 6x squared and you have minus 3x squared, this term carrying an x squared, this term carrying an x squared. These two terms are called like terms, right? Good? Nice. So the law is simple. We can simplify like terms. So you could only simplify like terms. Huh? So I'm going to highlight like terms here. And how we can simplify them? Using the laws of directed numbers. Right? So go back now a step. What are the laws of directed numbers? Two laws. Same signs and different signs. So as long as we can identify like terms anywhere, we can simplify those like terms. And how we can simplify them? Only using the laws of directed numbers. So you're going to move on to some examples now, right? Right. So ask yourself, are these like terms? Yes, they are like terms. Why they are like terms? Because they carry the same variable. Right? This one has an x squared, this one carrying an x squared. Okay, fine with that. Now, the law states we can simplify like terms using the laws of directed numbers. There's only two laws of directed numbers. So in this case, we know we're going to use the same signs law because the 4x squared carrying a positive and the 6x squared also carrying a positive. So we're going to add and keep the same sign, right? So this is plus 10x squared. Okay, we're good with that. Example again here now. Minus 3xy minus 7xy. Right. Are these like terms? Yes, they are like terms. Why they are like terms? Because they carry the same variable. So the variable here is xy, the variable here is xy. Could we simplify these terms? Yes. How we can simplify them? Using the laws of directed numbers, right? Which law of directed numbers apply to this example? The same signs law, right? So the same signs law here is add and keep the same sign. So 7, 8, 9, 10. So this is minus 10 xy. So when this is simplify and make it simpler, we took two terms, made it into one term. Two terms here again, made it into one term. That's what we call simplify. Make something simple, right? Good. Right. We have room for my example. You could do two more examples here. Right. So let me see this now. Minus 3ab plus 7ab. Okay. Are these like terms? Yes, they are like terms. Why? They have the same variable. Here have a AB, here have a AB, right? Okay. We established that these are like terms. So now we're going to apply the laws of directed numbers to simplify this like terms. But we need to be careful here. Which law of directed numbers we should apply here? Which law do you think we should apply? The same signs law or the different signs law? Anybody can answer? Anybody brave enough to answer?
The different signs law.
Different signs law. Excellent. Why different signs law? Let's study class why now.
Because one of the numbers,
it's positive.
One carrying a positive and the other carrying a negative. So one time we see different signs law. What is the different signs law?
Subtract it and keep the sign of the bigger number.
Excellent. So we're going to say subtract and keep the bigger sign. 7 take away 3 is 4. So we say this is plus 4ab, right? We're going to do our next example here, right? All right. So what about this one now? 2x minus 15x, right? Are these like terms? Yes, they are like terms because these terms carry the same variable. We see an x here and we see an x here. So we go to it. We understand now that this here are like terms. So we can simplify them using the laws of directed numbers. But now we need to decide which law of directed numbers we could use here. So which law of directed numbers we're going for? The same signs law or the different signs law? Anybody
Same
can answer?
signs law.
The
Same signs law.
same signs law. Right. So the same signs law now. So I'm going to ask you a question now. What is the sign of the 2x?
Positive.
Positive. It is understood to be positive, right? So let me use a different color here and put this here. I'm going to highlight this here to be positive, right? Good. And the sign of the 15x?
Is also positive.
How that is positive now? Look good. You see a negative sign here?
Yes.
Right. So we're still going to use the same signs law. We're going to use a different signs law.
Different signs law.
Different signs law. Nice. So you see how careful we need to be with this, right? Why we need to be careful with this and why I take my time with this is because in directed numbers, right, was simple. Was only numbers we're dealing with, right? Only numbers, right? That was simple. Now simplifying like terms now, it have you call these algebraic terms you're dealing with. Now when we're dealing with algebraic terms, you need to sort out the first thing first. Are they like terms? So you're looking at the variable, right? So when you have that in your head now, then you need to decide which law to use, right? So that's why we have to be extra careful. Two things we have to do here. Identify if it's like terms or not, and then now decide which law to use, right? So in this case here, now we're using the different signs law, which is subtract and keep the bigger sign. So we have here 15, take away 2 is 13, x, of course, and we keep the sign of the bigger number, right? Because we use the different signs law, right? Let us go back a second. Different signs law, we subtracting and keeping the bigger sign, right? So this here is extremely important. It's okay to make mistakes in the beginning. That is okay. That is part of the learning process. Because we make the mistakes now, so later down the road, we're going to master this, right? Good. Especially in mathematics. Mathematics is a topic. Feel free to answer at any time. Feel free to make mistakes in the beginning. When you make mistakes in the beginning, right, you just correct yourself, and later down the road, you're less likely to make mistakes because you already made that mistake already, right? Nice. So one misconception I want to deal with here, and I see this a lot, right? Because these are like terms we're dealing with, right? because these are like terms we're dealing with, some students automatically think because it's like terms, because here you would like, automatically we're going to use the same sign flow, right? Automatically we're going to use the same sign flow, right? And I get this misconception a lot, right? No, once they are like terms, there's two possible laws we could use. There's the same signs law and there's the different signs law, right? So don't forget that, right? So once it's a like term, not always the same signs law. The first two examples, yes, we use the same signs law here. But the next two, which law we use? We use the different signs law, right? So the signs here play an important role, right? And simplifying like terms, this is just the basic introduction to it, right? There are many more levels to this, right? Because sometimes now when we have to simplify terms, and there are about 6 terms in our expression, because they call this an expression, right? If you remember from last term, this is called an algebraic expression. There are more than one term here, so we call it an expression, right? Good. So when you have 6 and 7 terms to deal with, we need to rearrange the terms. And why we need to rearrange them for? We need to rearrange them to make sure they are like terms. For example, what I mean by that is, okay, like this is a class of 23 students right now in this class, right? So let me see now, we want to group these students and them here in this class, and we want to make some teams. We have a cricket side, we have a football side, we have a tennis side. So now we have to find out who like cricket, who's strong in cricket, who's strong in football, who's strong in tennis, as the case may be, who prefer to play in sports, so that at least if they're not strong in it, they enjoy playing sports, you know. So that's why now we have to rearrange all, you know. So we have a group here, we have a group here, and we have a group here, right? So you have 3 teams. So we simplify 23 students into 3 groups, right? So we have to rearrange now, right? So we understand the laws of directed numbers, yes, right? You don't have to write this. I'll send this in the group chat right after class. So, and then we understand now simplifying like terms, right? Like terms are terms with the same variable. Once you have the same variable, we can simplify them using the laws of directed numbers. And the laws of directed numbers are simple, 2 simple laws, right? Not only the same signs law there, but there's also the different signs law, right? So we're going on a little bit here now, right? Look at this example here. So we have here minus 2a squared plus 5a squared minus 3a minus 6a plus 11ab. Watch how much terms there are in this expression here. There are 1, 2, 3, 4, 5 terms here, right? Again, this falls under the topic simplifying like terms, right? So in order to simplify the like terms here, what we need to do, we need to identify first if there are any like terms, right? So take the time. Are there like terms? Yes, this is a pair like terms here, right? Why? They carry the same variable. Here carrying a squared, here carrying a squared, right? Next set of terms now. Minus 3a minus 6a, are these like terms? Yes, they are like terms. Why? They carry the same variable. Here carrying a and here carrying a. The 11ab now, watch what going on here, right? I seen a here, yes, but a goes with the b. So this is a AB term. This variable is a combined variable term. So the variable term here is not A, it is not B, but it is AB. So there are no other AB terms here. So this is an unlike term, right? So we call this here unlike term. Right. So what we're going to do here is we're going to simplify the like term still using the laws of directed numbers, but we need to be careful, right? So the first pair now, are these like terms? Yes, they're carrying the a squared. We understand that perfectly well, right? So now we can simplify this first pair using which law? We have the same signs law, we have the different signs law. Which law are we going to apply here? Anyone feel free to answer? Faris, which law do you think you're going to use here?
Same signs.
Same signs law, okay. Tell me the sign of the 5a squared. You tell me the sign of the 5a squared.
Positive.
And the sign of the 2a squared.
Negative.
Right, so are they same signs?
No.
Right, so you see where you can catch it? Again, once they are like terms, they could fall in 2 categories. Same signs or different signs. Again, sometimes we forget the different signs is okay, right? Right, these are the first 2 examples we're doing, right? Today's the learning process taking place, so you're going to make mistakes now, right? So, which law you think we're going with the same science law so far, so we're going to the next one?
Different signs.
Different science law. What is the different science law again?
Subtract and keep the bigger sign.
Excellent. So go ahead now and subtract from and keep the bigger sign.
5/8 square, 2a square,
5
3a square is done.
3a squared, right? So we say 3a squared. And to be more specific, we could put the positive sign here, right? Because we keep the sign of the bigger number, right? Good. Somebody else now. Let me see if we could do the next piece here now, right? Are these like terms? Yes, because I seen an a here and I seen an a here. Point to note, a squared is not the same as a, right? So if I was to group these two here, that would be wrong. This here I call unlike terms as well, right? I could only group a squared with a squared, a with a b with a b, and so forth and so on. Easy to identify, right? So this square here changes the whole meaning of the term, right? But later on, and when you learn more further topics in math, you're going to see the importance of that square as well, right? Nice. So let me see. Kyla. See Kyla here in class today. Kyla, which law we're going to use to simplify this pair like terms here?
Same signs law, sir.
Excellent. Why same signs, Kyla?
Because both 3 and 6 are negative.
Both 3 and 6 are negative. So what is the same signs law again?
Where you subtract and keep the same sign.
Okay, now you can see. Same signs. Look at it. We're going to
Add and keep the same sign.
right, nice. We're going to add and keep the same sign. So you see, because it's a subtraction sign here, it's so tempting to subtract these two numbers, right? Good. But no, the same signs law, we're going to add them. Add and keep the same sign, right? So what the answer going to be, Kyla?
Negative 9e.
Excellent. Negative 9e. It is very important that every term we have has a sign before it, and that sign is the sign basically in charge of that term, right? So we have here plus 3a squared minus 9a, and this 11b is called an unlike term. So we cannot simplify this with anything here. So what we're going to do with this 11ab, we're just going to leave it in the answer, right? For example, we play in sports again, right? We have the cricketers here, we have the footballers here. Most students say here what? I don't want to play any sports, right? So we can leave them out. We might leave them to score or help out with something, you know, help out the teachers with something or whatever the case may be. But you can leave out this person, right? So go ahead and take this down now. Right. So most of you finished writing the example, and we're going to continue here now with our next example, right? Because in mathematics, that's how we do. We have plenty of examples, and the more examples you do, we understand the topic better, and the more practice questions we do, we understand the topic better as well, right? So let me go on to our next example here now. Again, we're on the topic simplifying like terms. And how we simplify like terms? Using the laws of directed numbers. And remember, there are two laws. Last week we covered these two laws in detail, right? A quick recap of these laws here. And these laws are very important. Again, directed numbers is the key to doing algebra. And algebra is the key to secondary school mathematics, right? So we're going on again here. Look at this example here, right? So you have here minus 7x squared plus 3xy minus 2x squared plus 8x, right, minus 9xy. Good. So how many terms you have in this expression here? You have 1, 2, 3, 4, 5 terms again. 5 terms in this expression, right? So the topic again is to simplify the like terms, right? So in order to simplify the like terms, we need to identify if there are any like terms. If there are no like terms, we leave the answer there, so, right? We leave it there so in the answer. So like a volunteer now to help me pick out the first pair like terms. Pick out any pair because there are more than one pair, right? First pair like terms here. Anybody?
Negative 7x squared
Negative
and
7x squared.
positive 3 squared.
Positive
No. And negative 2 squared.
2x squared, right? Nice. So how we just pronounce this, we say this is x squared or x to the power 2, right? Right, so you did well there,
Okay.
right?
Thank you.
This is x squared or x to the power 2, right? So this is negative 2x squared. So this here is the first pair like terms, right? I just gonna highlight them here and rearrange them. So when I say I rearrange them, grouping them again. If I say, okay, all the cricketers go on this side, all the cricketers come in on this side here. So when you're moving, guess what? You're moving with your sign too. You know, you're just not moving it 2x squared alone. And that would be wrong, right? You're moving it minus 2x squared, so we're moving that together, right? Nice. So this is a pair like terms here. Yes, because this carrying a x squared, this carrying a x squared. We can simplify this pair like terms using the laws of directed numbers, right? Again, two laws of directed numbers. Decide which law we're going to use here. We're going to use the same signs law, right? Because I see a negative here and I see a negative here. Same signs, we're going to add and keep the same sign. So 7, 8, 9. So this is minus 9x squared, right? Anybody else now want to help more identify our next pair like terms here?
Positive 3xy and negative 9xy.
Excellent. Positive 3xy. So I'm going to regroup it here. Again, it's the same question we're dealing with, but just rearranging it to mind system, right? Positive 3xy, and then we have negative 9xy. Okay, right. So I see this is like terms because I see a xy here and I see a xy here. So we're good to go there, right? Next step now is to decide which law we're using. Because remember, there are two laws to simplify like terms. So which law we're going to use here? Continue.
Different signs.
Different signs law. So explain the different signs law now.
Subtract and keep the bigger sign.
Subtract and keep the bigger sign. So go ahead now, tell me answer.
I get negative 6xy.
Negative 6xy. Excellent work, right? We subtract this here and we keep the bigger sign, right? The sign of the bigger number. Right. So we finished here. We simplify all the like terms. Anything missing? Anything we leave out? No? Or we good there? We good there? Students?
The unlike term.
The unlike term. Excellent. The unlike term. The unlike term is positive 8x. There's no other x term here. The other term very close to it, yes. Right? But they are not the same. This is x squared, right? X to the power 2. This term was derived, right? Remember last time when we did algebra in detail? This is derived by saying x multiplied by x. Right? For example, 3 multiplied by 3 is 3 squared or 3 to the power 2. Same thing. X multiplied by x is x to the power 2. Right? So that is why it is totally different, right? And xy was obtained by saying x multiplied by y. And that's how we get this term here, this xy term, right? So x here is just 8x, positive 8x, we bring it down in the answer, right? We continue in here. Right, this is our unlike term, positive 8x. And now this is the answer here, right? So this is the answer for this question here. And I have a little short note here to write down along with this exercise. Right, there's only 2 examples we did, but we did these examples in detail. And these 2 examples tested both laws of directed numbers, and it also tested like terms and unlike terms. And an important point to note here, in the last line here, all these terms are unlike terms, right? So we cannot simplify nothing with anything here, right? So sometimes students have a need to say, okay, we're going to do a next step again. So we can simplify these 2 things and then these 2 things. No, right? All these things are unlike terms, so we leave them as is, right? Good. We don't simplify the x squared with x squared, xy with xy, no x term, so we leave that there, right? So go ahead and take this example down, and we have a little small note here now, right? We cannot simplify unlike terms, right? Basically, we cannot simplify them using the laws of directed numbers. So we leave them as is, right? And these 2 examples, if you understand these 2 examples, right, we're ready to move on to do bigger questions, harder questions. We can simplify a question with 10 terms because we know a few skills here. We have a few skills here. What are the skills we know so far? Number 1, we can identify like terms, right, by looking at the variables. Number 2, we could rearrange like terms now to suit, because we need to move them around sometimes. The first example, everything was there already. The a squared was grouped with the a squared, a was grouped with the a, the 11ab, we know it had no like terms, so that was one side. But the second example now showed that we could rearrange these terms on them. And when we rearrange the terms on them, we move any term with the appropriate sign, right? For example, when I move this plus 8x, right? Although it have nothing to simplify with, I'll leave it as plus 8x right through, right? Plus 3x came down to be plus 3x minus 9xy minus 9xy. Apply the different signs law here, right? Simplify that. Good. So again, first important thing, identifying like terms. Second thing, rearranging it to group the like terms together. And the third thing, the third skill we learned today is to simplify like terms using the laws of directed numbers. And there are two laws of directed numbers, the same signs law and the different signs law, right? Which is very, very important, extremely important, right? These laws here help you to add and subtract directed numbers, right? Good. So make sure and have the heading as well for this little two examples here. And the heading here was simplifying like terms. Right? Two examples here. We understand these two examples in detail. We have more exercises to do. We have more examples to do, right? And that we're going to do that for the rest of class here, right? So when you all finish writing, just let me know, right? Right. So a good bit of just finish writing here, right? And these notes I was sending in the WhatsApp group for you all. The revision notes here and the directed numbers. We have the simple examples here. Basically, just to introduce you to what we're going to do, right? And you see here, once there are like terms, you can simplify them. But we need to realize that there are two laws in simplifying, right? So we need to recognize which law it is, right? So I don't think anybody have problems identifying like terms. We did excellent so far. And rearranging, just be careful when you're rearranging terms, right? And unlike terms, make sure and include it in the answer as well, right? You cannot simplify it, you leave it as is in the answer, right? So let's record the first part of class for those who might have missed it. That's the teaching part. So now we're going to do some practice, and I'll like to join back the meeting. We'll do some practice questions. I'll like to participate. If you to participate, it's okay to make mistakes, right? We part of the learning process, right? And make sure you understand everything at the end of this class, right? So I went to any meeting, I'll like to join back, and we could continue with the examples, right?